Hi, this is Walter Stone, and this lesson is about special cases of factoring. And I'm going to present this lesson in two parts. And in this first part, we're going to learn how to factor binomials, which are differences of two squares, and factor polynomials, which are squares of binomials. So in the first objective here, we want to be able to factor binomials, which are differences of two squares. So to factor a difference of two squares, we can use the following pattern. So if we have something of the sort a squared minus b squared, we can factor that into a plus b times a minus b, where a is the square root of this a squared term, and b is the square root of this b squared term. And this works because if I multiply this back out and FOIL it, I'll have a squared from my first terms, negative ab from my outers, a times b from my inners, minus b squared. So that negative ab plus ab turns out to be 0, and we end up with a squared minus b squared. So for example, if we want to factor x squared minus 9, well, x squared minus 9, this is a difference. X squared is a square, 9 is a square number, so this is a difference of two squares. And it can be written as x squared minus 3 squared. And so using the pattern a plus b times a minus b, our a now is x, and our b now is 3. So if we write this as x plus 3 times x minus 3, those are the factors of x squared minus 9. Okay, so now in your note sheet you want to try out x squared minus 144. Turn off the video, try this problem, and I'll come back and show you the solution. Okay, so we're back. So x squared minus 12 squared is how we can rewrite this difference of two squares, because 12 squared gives us 144. So this fits the pattern of a difference between two squares. So we can write the factors as x plus 12 times x minus 12. Okay, so check your work and see if it matches with mine. Great, so let's take a look at the next example. So here we have 64x squared minus 121, and 64x squared is the square of 8x, 121 is the square of 11. So this is a difference between two squares. So using our pattern, we can write this as 8x plus 11 times 8x minus 11. So try this next one. So we want to factor 16x squared minus 1. Pause the video, come back, and check your work. Okay, so we're back. 16x squared minus 1, 16 is 4x squared, and 1 is 1 squared. So we have a difference of two squares, and we can use the pattern to write the factors 4x plus 1 times 4x minus 1. So check and revise your work, and if your work matches mine, that's great. And one thing we want to remember to do is we can multiply these back, and we should get 16x squared minus 1. So if I take 4x times 4x, that's 16x squared. The outers give me negative 4x plus the inners of positive 4x. So negative 4x plus 4x is 0. 1 times negative 1 is negative 1. Sometimes we'll have more than one variable, and we'll have powers that are squares. So here, y to the fourth is y squared squared. So we can take a look at 49x squared, that's the square of 7x. 25y to the fourth, that's the square of 5y squared. So we can write the factors 7x plus 5y squared times 7x minus 5y squared using our pattern. So this problem, try this problem is similar to this one. So you want to look for powers of the variable that are squares. Okay, so try this one and pause the video, try it out, and come back. Okay, so we can write 4m squared as the quantity 2m squared, and we can write 81n to the fourth as 9n squared squared. So 9 squared is 81, n squared squared is n to the fourth. We multiply the powers when we take a power to a power. So using our pattern, we have 2m plus 9n squared times 2m minus 9n squared. So check your work, see if things match up. Try foiling this out, and we should get 4m squared minus 81n to the fourth as our product of these two factors. Excellent. So we always want to be on the lookout for common factors. So with 7x squared minus 28, we automatically want to do this all the time. We want to see if there's a common factor. And in the preceding examples, there was just a common factor of 1, so we didn't have to worry about taking out a common factor. But here we have 7 as a common factor. So we can say that 7x squared minus 28 is equal to 7 times x squared minus 4. If we distribute this back, we get 7x squared minus 28. X squared minus 4 is a difference of two squares. So we can write the factors as x plus 2 times x minus 2. So our final factorization is 7 times x plus 2 times x minus 2. So I can't emphasize this enough. We need to factor out a common factor before we do any other factoring. So it's good to do examples that include these common factors. So try this one. So we want to factor 24x squared minus 54. Pause the video and try this one out, and then come back and check your work. Okay, we're back. On the side here, I know that there could be a common factor. Both 24 and 54 are even. So what I did was some side work. I looked at the prime factorizations of 24 and 54, and I see that we have a common factor of 2 and a common factor of 3. So 2 times 3 is 6. So I was able to factor out a common factor of 6. And so we have 6 times 4x squared to give us the 24x squared back, and 6 times negative 9 is negative 54. So distributing the 6 gives us back the 24x squared minus 54. I see that 4x squared minus 9 is a difference between two squares. So I can factor that as 2x plus 3 times 2x minus 3. So that allows us to write out the factors of 24x squared minus 54. If your work matches my work, that's excellent. One thing that you might want to do is, if you still have common factors, like if you just took a 2 out, you'd have 12x squared minus 27, and there's still a common factor of 3. So just make sure that you take all the common factors out as you factor these polynomials, that you find the greatest common factor. The second objective of this lesson, we want to work with what are called squares of binomials. So we have trinomial squares, they're called. Okay, so if I have x squared plus 6x plus 9, I can write that as x plus 3 squared. And because if I write this as x plus 3 times x plus 3, the first will be x squared, the outers will give me 3x, the inners will give me 3x, and the last give me 9. And that 3x plus 3x gives me the 6x. So what happens is if the first and last terms are squares, and there's no minus sign in front of these, because if I square a real number, I get a positive number. And if I can take the square roots of each of these, so the square root of x squared is x, the square root of 9 is 3, and x times 3 is 3x. And if I double that result, I get 6x. So if I can do that, then I have what's called a trinomial square. So is the trinomial x squared plus 10x plus 25 the square of a binomial? Well, x squared and 25 are squares. There's no minus sign in front of those. If I multiply the square roots of x squared and 25, I'm multiplying 5 by x, and I double that, I get 10x, and that is the middle term. And so doing that test, I see that that trinomial is a perfect square. Is x squared plus 8x plus 13 the square of a binomial? Well, 13 is not a perfect square. So since the last term is not a perfect square, it's not a perfect square binomial. So it wouldn't, we wouldn't use these ideas on this for this to factor this type of trinomial. We go back to x squared plus bx plus c, see if there are factors of 13 that add up to 8. So here we just want to make sure we can see the patterns and be able to work with these. So if we have x squared plus 2ax plus b squared, that factors into a plus b squared. So if the sign in front of 2ab is positive, we have a plus b quantity squared. If the sign in front of 2ab is negative, we're going to have a minus b squared. Okay? So suppose we want to factor 9x squared minus 30x plus 25. Well, that can be, 9x squared can be written as 3x squared minus 30x plus 5 squared. And a is 3x and b is 5. So a times b is going to be 3x times 5. And if we double that, do we get back to negative 30x? Well, we do. Negative 2 times 3x is negative 6x times 5 is negative 30. So this is a trinomial square. And so this is of the form ax squared minus 2ab plus b squared. And we know that factors into a minus b quantity squared. So we can take a as 3x, b as 5, and write 3x minus 5 quantity squared. So here you can try this one. Suppose you have 9y squared minus 42y plus 49. Pause the video and come back and check your work. Okay, so here we have that 9y squared can be written as the quantity 3y squared. 49 is 7 squared. And if we take negative 2 times 3y times 7, we get negative 42. So 3y times 7 is 21 times negative 2 is negative 42. So this is of the form of a trinomial square, so we can write it as 3y minus 7 squared. Here we want to always be on the lookout for a common factor. Okay, so the main rule for factoring is we want to make sure we factor out any common factors. So with 242x squared plus 88x plus 8, we see that 2 is a common factor. So 2 can be multiplied by 121x squared to get the 242x squared. 2 times 44x is 88x. 2 times 4 is 8. So we factored out 2. Now 121 is 11 squared. So 121x squared we can write as the quantity 11x squared plus 44x plus 2 squared gives us the 4. So inside the parentheses I have 11x squared plus 2 times 11x times 2 brings us back to 44x plus 2 squared. So here inside these parentheses we have the pattern. We can use a plus b squared. So we can take 2 times 11x plus 2 quantity squared to bring us back to the original polynomial. So what I suggest you do is you FOIL that back out and make sure it multiplies back to give us this product. And I think we're doing all the right things along the way. So we have a rationale to think that this is correct. Okay? So let's try this one. So here we have 25y squared minus 100y plus 20. Try this out and then come back. Okay, so I did some work here and I saw that we had a greatest common factor of 5. And when I took the 5 out, 5 times 5y squared gives me 25y squared. 5 times negative 20 is negative 100, and 5 times 4 is 20. And 5y squared, so 5 is not a perfect square. It's not 1, 4, 9, 16, 25, or 36. And I also see that there are no other common factors. And when I work with my ax squared plus bx plus c type of factoring here, there are no factors of 20 that add up to negative 20. So this is not a factorable trinomial. It's called prime. So it turns out we cannot factor this as a perfect square trinomial. So sometimes things like this happen, okay, when we won't have a perfect square trinomial. But in your practice, you'll probably see more cases where you have a common factor and a perfect square that multiplies back in this type of lesson. Okay, so one thing to do is try the written examples on this sheet and work with the written exercises, and also do the online work for this section, and we will see you in class. Take care.